Hello, and welcome to the Sleepy Dust Records. Find your comfortable space now. Allow your body to settle completely, to feel the full support of the surface beneath you. Become aware of the gentle contact points, your head on the pillow, your shoulders against the mattress, the weight of your arms and your legs. Notice the weight of the blanket, a gentle, reassuring pressure. Notice the coolness of the pillow against your skin. Let your arms and legs feel heavy, wonderfully, deeply heavy, and relaxed. Let your shoulders soften and release, melting away from your ears. Allow your jaw to unclench, and your brow to become perfectly smooth. Take a slow, deep breath, feeling the air gently fill your lungs, a cool, clean breath of night air. And as you exhale, release the day. Let go of every thought, every worry, every plan. Imagine them as little clouds, drifting away on the tide of your breath, leaving behind a clear, quiet sky of the mind. There is only stillness behind. With each breath, you sink a little deeper into comfort, a little further into peace. Tonight's story is a true story. It is not a story of people or places on this earth, for it began long before the earth existed. It is a story that is far older, far grander. It is a journey that lasted for billions of years. A journey that ends with you, resting here now in this moment of perfect peace. You see, you are made of stardust. This is not just poetry, it is a profound and literal truth. The iron in your blood, that which carries life-giving oxygen through your body, was forged in the explosive death of a massive star, an ancient supernova that seeded the cosmos with heavy elements. The calcium in your bones, giving you strength and form, was born in a stellar furnace. The carbon that forms the basis of every cell within you, the very architecture of your being, was created in the heart of a star like the one in our story tonight. Every atom that makes you you was once part of a star that lived and shone and died long, long ago. We are all walking constellations, carrying the legacy of the cosmos within us. Tonight, we will follow the journey of one particular traveler, a tiny, physical speck of dust, a pre-solar grain. It is older than our sun, older than our earth. A true grain of stardust, a messenger from a time before our own. Scientists have found these grains, these tiny, resilient time travelers, locked away like jewels inside meteorites. By studying them, they can read the story of the star that made them. They are real. They are physical pieces of other stars that you could hold in your hand. Imagine this tiny speck, smaller than the width of a single human hair. Perhaps it rests now deep within a meteorite, half buried in the silent blue ice of Antarctica, where the wind is the only sound and the sun circles the low horizon for months on end, casting incredibly long, slow-moving shadows. Or perhaps it lies in the warm red sand of a silent desert, like the Atacama or the Sahara, under a sky so clear and filled with a billion stars that the Milky Way looks like a river of light, a sky untouched by city lights. Or maybe it was washed into the sea countless ages ago, and now rests on the dark, quiet ocean floor, in the crushing pressure of the abyss, where the only light is the faint, ghostly bioluminescence of passing creatures, strange and beautiful forms of life that create their own light in the eternal darkness. Wherever it is, it holds a memory. It holds a story, encoded in its very structure. And tonight, we will listen. We will let our minds travel with this grain, becoming as small and as patient as this ancient speck of dust. So close your eyes, if you haven't already, and let us begin the journey, not across the world, but across the cosmos, and across the unfathomable depths of time itself. Our story begins an impossibly long time ago. So long ago that our own solar system was not even a dream. It was just a cold, dark, and featureless cloud of gas, waiting for a signal, its story yet to be written. Our story begins in a place of unimaginable heat and light. It begins inside a star. This star is not like our sun. Our sun is young and vibrant, a yellow dwarf in the serene prime of its life. This star is ancient, nearing the end of its long existence. It has lived for billions of years, and now it has swelled into what is known as an asymptotic giant branch star, a red giant. Imagine a colossal luminous sphere. Its surface a deep, glowing ruby red, churning with slow, majestic currents of plasma. It is so vast that if it were in the place of our sun, it would swallow Mercury, Venus, and perhaps even our Earth. Its light is not the bright, sharp light of youth, but the deep, soft, weary glow of old age, a light that speaks of eons of slow, patient burning. This old star breathes. It experiences thermal pulses, great flashes of energy from a shell of helium burning deep within. These pulses cause it to gently expand, and then contract over thousands of years. Its heartbeat is slow, measured in centuries, a deep resonant pulse that sends vast spherical shock waves out into the space around it. Deep within its core, the furnace has spent eons performing a cosmic alchemy. For billions of years, it has been fusing lighter elements into heavier ones. It has taken the simple hydrogen and helium of its youth and transformed it into precious cargo: carbon, oxygen, silicon, the very building blocks of worlds and of life. Now, in its old age, the star performs a special process called a dredge-up. The turbulent, boiling motions inside the star, like a great, slow convection, dredge up these new, heavier elements from the core and bring them to the surface. The star's atmosphere becomes enriched with this new material. It is a vast, swirling haze of newly born atoms, a stellar wind carrying the seeds of future worlds. And it is here, in this relatively cooler outer atmosphere, that our journey begins. The temperature is still incredibly hot by our standards, thousands of degrees, but for a star, it is cool enough for a miracle to occur. Atoms, freshly forged, begin to meet in the stellar wind. They are no longer trapped in the furnace. They are free to find each other. An atom of silicon, born in the deep furnace, finds an atom of carbon. They join in a bond that is strong and true. Another joins them, and another. Slowly, patiently, over a grade of time, a tiny crystal begins to grow. A solid speck in a vast sea of glowing gas. A point of order in a universe of chaos. This is our first traveler, a grain of silicon carbide, tough and resilient, destined for a long journey. This is the moment of birth for our Stardust grain. A tiny shard of silicon carbide, condensing directly from the breath of a dying star. It is pristine, perfect, a physical record of this moment in time, this place in the galaxy. It floats in the deep red glow of its parent star, a tiny, silent witness to the final magnificent moments of a star's life. It knows nothing but the slow pulse of the giant, the gentle stellar winds, and the deep humming song of its creator. It is a child of the star, born not from its fire, but from its cooling breath. But our grain is not the only traveler beginning its journey. Elsewhere in the galaxy, at another time, a different story is unfolding. This story does not begin with a gentle sigh, but with a cataclysm. Imagine a star far more massive than our Sun, a true giant, a blue supergiant, burning through its fuel at a ferocious rate. For millions of years, it has been a brilliant beacon in the cosmos. But its time is coming to an end. In its core, it has created heavier and heavier elements, all the way up to iron. And with iron, the fusion stops. The furnace goes out. In a fraction of a second, the star's immense gravity, no longer supported by the outward push of fusion, takes over. The core collapses catastrophically. The outer layers of the star, billions upon billions of tons of matter, come crashing down, then rebound off the impossibly dense core in a titanic explosion. A supernova. For a few weeks, this single exploding star will outshine its entire galaxy. The energy released is beyond comprehension. In this inferno, even heavier elements are forged: silver, gold, platinum, uranium. The very fabric of space and time is rocked by the blast. And in this expanding fireball, a new kind of stardust is born. Not gently condensed, but violently forged and blasted outwards. Let us imagine a second traveler, born in this fire. Perhaps it is a tiny grain of graphite, pure carbon. Or maybe it is a nanodiamond, forged in the shockwave's incredible pressure. Or a grain of silicate, rich with the oxygen created in the star's final moments. This grain is different. It does not know the slow pulse of a red giant, but the singular defining violence of the supernova. It is a child of fire, a shard of the explosion. This new grain, our supernova sibling, is hurled into space at incredible speed, riding the shockwave of its parent star's demise. It is a tiny fleck of darkness, a speck of soot from a cosmic fire, carrying within it the memory of an explosion that lit up the cosmos. Its journey, too, has begun. And so, our two travelers, born of such different parents, begin their long voyage. One, the silicon carbide grain, drifts gently away from the glowing ghost of its red giant parent. The other, the graphite grain, rockets away from the expanding, shredded remains of a supernova. For hundreds of millions of years, they drift. They are separated by unimaginable distances, perhaps thousands of light years, yet they are part of the same great cosmic cycle. They are seeds, cast into the interstellar medium, the thin, cold gas and dust that fills the space between stars. Imagine their parallel journeys. They tumble slowly, end over end, on their epic voyages. They travel through regions of utter blackness, the great voids between the arms of the galaxy, where the nearest star is a faint, distant pinpoint of light, a diamond on black velvet. They feel the faint whisper of the interstellar magnetic field, a gentle unseen current guiding their paths, a cosmic river flowing through the void. Sometimes, their long journey takes them through places of breathtaking beauty. Perhaps the silicon carbide grain passes through an ancient globular cluster, a dense, glittering city of 1,000,000-old red stars. The graphite grain, on its faster course, might slice through the glowing tendrils of a vast nebula, a place where new stars are being born, its dark form a stark contrast to the swirling curtains of pink, blue, and purple gas. They witness the slow, graceful dance of galaxies. From their perspectives, entire galaxies, each containing billions of stars, are just glowing spiral-shaped islands in the far, far distance. They see them age, their light shifting over eons. Time moves differently here. 1,000,000 years pass like a single day. They are patient travelers, messengers from stars that are now just fading memories. one a tiny white dwarf, the other a rapidly expanding cloud of gas. They carry the physical essence, the stories of their birth, across the void. In the deep void, our silicon carbide grain continues its slow tumbling journey. For 1,000,000 years, nothing changes. The distant stars are fixed points of light. The silence is absolute. But the void is not truly empty. It is crisscrossed by invisible high-energy particles, the shrapnel of cosmic cataclysms. These are cosmic rays. One such particle, a proton, was accelerated to nearly the speed of light by the magnetic field of a spinning neutron star, the crushed remnant of a supernova. For 10,000,000 years, it has traveled across the galaxy, an unstoppable, invisible bullet. By pure chance, its path intersects with our tiny grain of stardust. There is no sound, no flash of light. But in that infinitesimal moment of impact, there is a release of energy. The proton slams into the crystal lattice of the silicon carbide. The impact shatters a handful of atomic bonds, creating a tiny microscopic scar, a damaged track deep within the grain structure. A few atoms are knocked out of their perfect, ordered alignment. For our tiny grain, this is a moment of profound violence. Its perfect, pristine structure, formed in the gentle breath of a red giant, is now forever marked. It carries a wound from the void. But the grain is strong. The damage is contained. The vast majority of its structure remains intact. It continues its journey, tumbling on as before, but now it carries a new memory, a new story. A story of survival. A story of enduring the unseeable dangers of the great, empty dark. Not all grains are as fortunate. Let us imagine another grain, born from the same red giant, at the same time as our silicon carbide traveler. This grain is not made of tough silicon carbide, but of a more fragile, amorphous silicate. It is like a tiny speck of glass. It has traveled alongside our grain for eons, a silent companion on the same cosmic river. It too tumbles through the void. But its journey is about to end. It drifts into a region of space that is slightly denser, a wisp of a hydrogen cloud. And here, it encounters a different kind of danger. The young, hot, blue stars of a nearby stellar association are bathing this region in intense ultraviolet radiation. This radiation is a form of light, but it is a harsh, energetic light. It strikes the fragile silicate grain. Unlike the tough silicon carbide, the silicate's looser atomic bonds cannot withstand the assault. The ultraviolet photons act like tiny hammers, chipping away at the grain, one atom at a time. This process is called sputtering. Slowly, over thousands of years, the silicate grain is eroded. It shrinks, its substance returned to the void as individual atoms of silicon and oxygen. It dissolves back into the nothingness from which it came, its long journey ending not with a bang, but with a slow, silent disappearance. Our silicon carbide grain, protected by its stronger bonds, passes through the same region unharmed. It is a survivor, its resilience tested and proven. It now travels on alone, carrying the silent memory of its less fortunate companion. Let us now imagine a third kind of traveler. This one has no parent star. It is a cosmic orphan, born not in fire, but in the absolute cold and darkness of the interstellar medium itself. In the densest, coldest parts of a molecular cloud, where no starlight can penetrate, the temperature drops to just a few degrees above absolute zero. Here, the gas is so cold that atoms move incredibly slowly. Over immense periods of time, something remarkable happens. Individual atoms of carbon, silicon, and oxygen, long ago expelled from stars, find each other in the dark. They don't have the heat of a star's atmosphere to help them bond. Instead, they use the surfaces of other older dust grains as meeting places. An atom of carbon lands on an icy grain, and another joins it. Slowly, patiently, new molecules form. And then new solid grains begin to grow, not from a stellar breath, but from the slow, cold accretion of the void itself. This third grain is different from the others. It has no single story of a parent star. It is a composite, a mosaic of atoms from countless different stellar sources, brought together in the deep cold. It is a child of the void itself. Its structure is not crystalline, but amorphous and disorganized, a jumble of atoms held together by the gentle frost that coats it. It is fragile, and it carries the memory of the deep creative silence between the stars. This cosmic orphan, too, will join the great gathering. After an immense time drifting, an age so long it is beyond our comprehension, the journeys of our three grains begin to converge. The gentle, unseen currents of the galaxy, the great, slow rotation of the Milky Way, guide them towards the same destination. They are no longer in the near-empty void, but are entering a giant molecular cloud. Imagine this place. It is a vast, dark, and cold region of space. It is a cosmic cloud, hundreds of light-years across, composed of molecular hydrogen gas and interstellar dust. It is dark because the dust within the cloud is so thick it blocks the light from all the distant stars. The silence here is different. It is not the empty silence of the void, but a thick, muffled quiet, the silence of a cathedral before the service begins. Our silicon carbide grain drifts into one edge of the cloud. Millions of years later, our graphite grain, the child of the supernova, arrives as well. And our third traveler, the cosmic orphan, is already here, having been born in the cold darkness. They are now part of the same great gathering, a cosmic reservoir. They are no longer alone. They are joined by countless other dust grains, from countless other long-dead stars. Each one is a tiny messenger from another time, another place. They mingle here in the cold and the dark, a silent community of travelers, a congregation of cosmic refugees waiting for a new purpose. Here in the deep cold of the cloud, just a few degrees above absolute zero, something new and wonderful happens to all of them. Their hard surfaces become tiny sanctuaries. Molecules of gas, like water, carbon monoxide, carbon dioxide, and methane, which have been drifting freely, gently collide with the grains. In the intense cold, they cannot bounce off. They lose their energy and stick. They freeze, coating all three of our ancient travelers in a thin, icy mantle. Layer by layer, an ice frost grows, a delicate, fluffy coating of frozen gases. They are now seeds, coated and ready for planting. They drift slowly within this great dark womb, this stellar nursery. It is quiet, it is cold, and it is patient. The cloud is a place of potential. It holds all the raw material needed to build new stars and new worlds. For now they just drift, waiting for a sign, a signal to begin. The long, quiet waiting is about to end. Perhaps the shockwave from another distant supernova, a dying star's explosive farewell, ripples through the molecular cloud. This gentle cosmic push, traveling for thousands of years, is enough to disturb the delicate balance. Gravity, which was always there, a patient and constant force, now begins to win. The cloud begins to collapse. Slowly at first, then with gathering momentum, regions of the cloud begin to contract under their own weight. It is like a great, slow inhalation, lasting for millennia. Our three stardust grains, the child of the red giant, the child of the supernova, and the orphan of the void, are caught in the same collapsing core. Imagine being part of this immense, slow-motion infall. The grains, along with trillions upon trillions of others, begin to drift towards a common center. As the cloud contracts, it begins to spin, faster and faster, conserving its angular momentum, like a skater pulling in their arms. The spinning motion flattens the collapsing cloud into a vast, rotating disk of gas and dust. This is a protoplanetary disk. This is the spinning nebula that will become our solar system. At the very center, the material becomes hotter and denser. The pressure builds to an unimaginable degree. A protostar ignites, our own sun, in its infancy. It is not yet the bright yellow star we know, but a hot, churning, furious ball of gas, a T-Towery star, glowing with the raw heat of its own compression. It is a wild young star, shooting out powerful jets of gas from its poles. Its light is the first light to shine in this new system, and it pushes out a fierce solar wind, clearing away the nearby gas. Our grains are now part of this swirling disk, the solar nebula. They orbit the young sun, caught in a cosmic dance with countless other particles. They have survived the death of their parent stars, their long journey through the void, and now they are building blocks in a new solar system. They are seeds of the past, ready to be planted in the fertile ground of the future. Our grains are not alone in the protoplanetary disk. They are part of a vast construction site, and they are about to witness the birth of a giant. Further out in the disk, beyond the snow line where it is cold enough for ice to persist, a runaway process begins. A small rocky core, perhaps 10 times the mass of the Earth, has grown large enough that its gravity starts to pull in the vast amounts of hydrogen and helium gas that make up most of the disk. At first, the process is slow, but as the core grows, its gravity becomes stronger, and it pulls in gas faster and faster. A feedback loop begins. More mass means more gravity, which means more gas is captured. Our grains, orbiting nearby, feel the gentle but inexorable pull of this new center of gravity. Their orbits are subtly altered. They are witnessing the birth of Jupiter. This is not a gentle process. The gas falling onto the growing planet creates immense shock waves and turbulence. The region around the young Jupiter becomes a chaotic, swirling vortex. Our grains are tossed and turned, swept up in currents of infalling gas. They may be pulled close to the growing giant, feeling the heat of its formation, before being flung back out into a different orbit. For 100,000 years, this process continues, until the young Jupiter has swept its orbit clean, becoming the undisputed king of the new solar system. Its immense gravity will now dictate the fate of countless other objects. It will act as a great shepherd, protecting the inner planets from many impacts, but also flinging others, like the asteroid that will one day carry our grains, onto new and interesting paths. Our grains have survived the birth of a giant, and are now part of a more orderly, more structured solar system. The solar system is not yet settled. The giant planets, Jupiter and Saturn, are not in their final positions. They begin a slow, gravitational dance, a grand migration. Imagine Jupiter, born further out, slowly moving inwards, its immense gravity scattering the asteroids before it like a great cosmic snowplow. This is the grand tack. For a time, it seems Jupiter might continue all the way to the inner solar system, destroying the young rocky planets that are trying to form there. But then Saturn, the second giant, also begins to migrate. It catches up to Jupiter. They fall into a gravitational resonance, an orbital lockstep. For every 2 times Jupiter orbits the Sun, Saturn orbits once. This resonance changes everything. The dance shifts. The inward migration of Jupiter is halted, and then reversed. The 2 giants begin to move outwards together, towards their modern-day orbits. Our asteroid, carrying our precious grains, is caught in this great gravitational tide. It is tossed about, its orbit stretched and tilted. It is a tiny boat in a gravitational storm. It may be flung into a much wider, more eccentric orbit, or pushed closer to the Sun. This chaotic dance is what gives the solar system its final shape. It explains the small size of Mars and the composition of the asteroid belt. Our grains are silent witnesses to the great architectural ballet that sculpted their new home. The protoplanetary disk is a chaotic place. It is a cosmic garden, but a wild and untamed one. Our 2 grains, orbiting the young Sun, are swept up in turbulent eddies and currents of gas. The inner part of the disk, near the hot young Sun, is a place of fire. The intense heat vaporizes the icy mantles of any grains that stray too close. Here, another kind of creation is happening. Clumps of dust flash heat to thousands of degrees, perhaps from shock waves or lightning in the nebula. They melt into tiny, fiery droplets of molten rock. As these droplets cool, they crystallize into small glassy spheres. These are chondrules. They are one of the oldest and most primitive materials in our solar system. Our graphite grain, the child of the supernova, finds itself swept into one of these fiery events. Its icy mantle instantly evaporates. It is caught on the surface of a molten droplet. For a moment, it experiences a heat not felt since its birth in the supernova. The droplet cools rapidly, and the grain is locked inside, a tiny dark speck in a glassy sphere. It is now part of a chondrule. Meanwhile, our silicon carbide grain, the child of the red giant, remains further out in the disk, in a cooler, calmer region. It tumbles through clouds of other ice-coated grains, its own icy mantle still intact. The disk is a place of constant mixing. Material from the outer regions is dragged inwards, and material from the inner regions is flung outwards. Chondrules, like the one carrying our graphite grain, are scattered throughout the disk. The stage is now set for the final act of creation. The building blocks are all here, ancient grains from distant stars, some naked, some coated in ice, and newly formed chondrules, the fiery children of the nebula itself. All are swirling together in a slow cosmic dance. In the cool, swirling disk, the final assembly begins. The chondrule containing our graphite grain gently bumps into the ice-coated silicon carbide grain. They don't bounce apart. The sticky, icy mantle of the silicon carbide grain acts like a gentle glue. They stick together. Another ice-coated grain joins them. A clump of simple dust. A tiny, amorphous silicate. This tiny, fluffy clump tumbles through the disk, gathering more and more particles. A soft collision here, a gentle connection there. This is the beginning of a planetesimal, a small planetary body. Over thousands of years, the clump grows from a fluffy aggregate into a solid pebble, then a rock, then a boulder the size of a mountain. Our two ancient grains, born so far apart, are now neighbors, buried together deep inside this growing body. They are protected, sealed away from the harsh radiation of the young sun. Their world has become one of rock and silence, tumbling through its orbit. Inside this growing asteroid, radioactive elements decay, generating heat and melting some of the ice, allowing new minerals to form around our ancient grains, locking them even more securely in a stony matrix. This process, called aqueous alteration, transforms the asteroid's interior into a complex mixture of rock and clay, a perfect vessel to preserve our travelers. Their wild journey through open space is over. Now, their existence is one of stillness. They are part of a larger whole, a carbonaceous chondrite asteroid, rich in water and carbon, drifting in the cold, dark space between the newly forming planets of Mars and Jupiter. It is a time capsule, locked in stone. For billions of years, it orbits the Sun in silence, a silent passenger carrying the memory of two different stars, from two different times. Our asteroid's existence is one of stillness, but the young solar system is not a peaceful place. This is the era of the late heavy bombardment. The newly formed planets are still clearing their orbits. The solar system is a cosmic shooting gallery. Our asteroid, in its quiet orbit, is a silent witness to this violence. From its surface, the sky would be filled with the streaks of other asteroids and comets, some on chaotic, plunging orbits. It would see the distant flash of immense impacts on the young Earth and Moon, collisions that would resurface entire hemispheres and throw up vast clouds of debris. Our asteroid has near misses. Another large planetesimal may pass by, close enough for its gravity to be felt, a gentle tug that slightly alters our asteroid's spin. It may pass through the debris trail of a shattered comet, a gentle rain of tiny ice particles pattering against its surface. This is a violent piece. The stillness of our asteroid is punctuated by the distant chaos of a system settling down. Our grains, buried deep inside, are protected from this. They are shielded by kilometers of rock. They feel nothing of the impacts and the chaos. They are in a deep, stony sleep, while the solar system rages outside. This period of violence is essential. It delivers water and organic molecules to the young Earth, setting the stage for the next great chapter of creation. Our asteroid and the precious stardust within it is a pristine relic of a time before this great bombardment, a perfect sample of the raw materials from which the planets were made. Let us imagine the young Earth during this time. It is a hot, volcanic world, shrouded in a thick atmosphere of steam and carbon dioxide. It is a world waiting for a change. And the change comes from the sky. For millions of years, asteroids and comets, just like the one that carries our grains, rain down upon the Earth. These are not just sterile rocks. They are rich in water, locked away as ice. They are rich in organic molecules, the building blocks of life. Each impact delivers a tiny amount of water, but over millions of years, this cosmic rain adds up. The steam in the atmosphere condenses. The clouds grow heavy, and for the first time, it begins to rain. Not for an hour or a day, but for centuries. A great, planet-spanning deluge. The rain fills the craters and the basins, and the first oceans are born. Our asteroid, still orbiting safely in the asteroid belt, is a sibling to the very asteroids that brought the water to our world. The water in our oceans, the water that makes up most of your body, was delivered to the Earth by these cosmic travelers. Our grains are part of this great story, a story of how a dry, rocky world was transformed into a blue water world, ready for life. After more than 4.5 billion years orbiting the Sun, an eternity of silent circles, a final chance encounter changes the asteroid's path. A subtle cosmic nudge from the giant planet Jupiter alters its trajectory just enough. Its long, stable orbit is broken. It is sent on a new path, one that drifts slowly, over millennia, towards the inner solar system, towards a beautiful blue and white world. Our world. It crosses the orbit of Mars, a silent, red sentinel. It drifts closer to the Sun, the light growing ever so slightly brighter, the warmth a faint touch after billions of years in the cold. Finally, its path intersects with Earth's. From the surface, it would be a spectacular sight, a reward for a patient sky watcher. A shooting star, a meteor, streaking across the night sky in a brilliant fiery blaze. For a moment, it outshines every star. The rock, which has known only the cold vacuum of space, is suddenly met with the friction of Earth's atmosphere. It is heated to thousands of degrees, glowing brighter than Venus as it compresses the air before it, creating a sheath of superheated plasma. The different elements in the rock, silent for so long, now announce themselves with color. A streak of orange from sodium, a flash of green from nickel, and a brilliant, searing white from magnesium. A final, fleeting moment of light. Most of the rock burns away in this intense fiery embrace, turning back into the gas and dust from which it came, a final offering to the atmosphere. But a small, hardy fragment survives the fall. The core of the asteroid, dense and strong, withstands the inferno. It slows, the fire extinguishes, and it falls the last few miles in darkness, a silent stone dropping from the sky. It lands, not with a great crash, but with a soft thud, in a place where no one sees it. Perhaps it falls into the vast, empty desert of Nullarbor in Australia, where it will be bleached by the sun for 1,000 years, becoming almost indistinguishable from the limestone rocks around it. Or perhaps it lands on the immense frozen expanse of the polar ice cap in Antarctica, where it will be quickly buried by snow, its dark form a stark contrast to the white, preserved in the deep, sterile cold. And there it rests. The journey is over. The motion has ceased. After a voyage across interstellar space, after billions of years orbiting the Sun, it has found its final harbor. Let us imagine our meteorite has landed in Antarctica. It lies on the surface of the vast ice sheet, a dark stone in a world of white. The silence is profound, broken only by the whisper of the wind and the distant crack of the ice. The next snowfall buries it. And the next. And the next. Year after year, century after century, the snow accumulates. The weight of the new snow compresses the layers below, turning them into dense glacial ice. Our meteorite is now entombed. It is sinking slowly into the glacier. Its world is now one of immense pressure and deep, deep cold. It is a world without light, without sound, without change. It is suspended in time, perfectly preserved in its icy coffin. But the ice is not still. The glacier is a river, moving at an imperceptibly slow pace. Over thousands of years, our meteorite is carried along with the flow of the ice, moving from the high interior of the continent towards the sea. It is a journey of millimeters per day, a slow, patient procession. Inside the meteorite, our stardust grains feel nothing of this. They are in a state of suspended animation, their long story paused. They are waiting for the ice to give up its secrets, waiting for the end of their long, cold sleep. As our meteorite sinks into the ice, it becomes part of a great library. Each layer of snow that falls on Antarctica traps tiny bubbles of air. These bubbles are a perfect sample of the Earth's atmosphere at that moment in time. The deeper you go into the ice, the further back in time you travel. Our meteorite, with its stardust from before the solar system, comes to rest alongside layers of ice that hold the air from the time of the Roman Empire, from the last ice age, from the dawn of humanity. It is an archive of archives, a message from another star, resting inside a library of Earth's own history. Scientists who drill ice cores are reading this library. They can analyze the ancient air in the bubbles and learn about the climate of the past. And when they find a meteorite like ours, it is a special discovery. It is a place where two great stories, the story of the stars and the story of the Earth, have come together in a single frozen place. The stardust is a visitor, a guest in the great, silent library of the ice. But the story is not quite over. The journey of the stone has ended, but the journey of the grains is about to begin anew. Let us imagine our meteorite has landed in a temperate forest. For centuries, it sits half buried in the soil, covered by fallen leaves. Rain falls upon it. The water, slightly acidic, begins the slow, patient process of weathering. Winter frost expands tiny cracks. The roots of a nearby tree wrap around the stone, their own gentle acids helping to dissolve it. Slowly, over an immense span of time, the meteorite crumbles. The stony matrix that held our grains so securely gives way. One day, a heavy rain washes our tiny silicon carbide grain and the chondrule containing our graphite grain out of the crumbling rock and into the rich, dark soil. They are now part of the earth. A tiny stream, born from the rain, carries them downhill. They tumble along the streambed, now surrounded by grains of quartz and feldspar from the earth's own rocks. The stream flows into a river, and the river carries them on a long, slow journey towards the sea. They may rest for 100 years on a sandbar, before another flood picks them up and carries them further. Eventually, the river slows, and our grains settle on the bottom of a quiet lake, or in a coastal estuary. They are buried by layers of mud and silt. Over millions of years, the weight of these layers presses down, turning the sediment back into rock. Our grains are once again entombed, but this time, in a terrestrial sedimentary rock. Millions of years pass. The continents drift. Mountains rise and fall. The rock layer containing our grains is slowly uplifted, becoming part of a new mountain range. And the process of weathering begins again. The rock erodes, and once more, our grains are freed. They are now part of the soil on a sunny hillside. While one meteorite was slowly becoming part of the earth, another, from a different fall, landed in the sterile ice of Antarctica. This is the one that is found by scientists. This is the one that is taken to a laboratory. Inside this lab, the real work begins. The rock is carefully cut, and a slice is polished so thin that light can pass through it. Under a powerful microscope, a world of texture is revealed. And there, a scientist sees it. A tiny crystalline inclusion that has a different composition, a different signature, from everything around it. A grain of silicon carbide. And nearby, a glassy chondrule with a speck of graphite inside. Using incredibly delicate instruments, they carefully, painstakingly, analyze these grains. They read the story locked within them, the story of the red giant, the story of the supernova. A message in a bottle, delivered across an ocean of time, has finally been opened and read. But what of our other grains, the ones now resting in the soil of a sunny hillside? A wild strawberry plant grows there. Its roots reach down into the soil, drawing up water and nutrients. And with those nutrients, it draws up our tiny graphite grain. The grain itself is inert, but the ancient carbon it is made of becomes part of the plant. It is incorporated into a sugar molecule, then into a cellulose fiber in a leaf. The stardust, born in a supernova, is now part of a living thing, reaching for the sun. The strawberry leaf, holding our ancient carbon atom, lives its life in the sun. It performs photosynthesis, turning light into life. But its time is fleeting. In the autumn, the leaf turns a brilliant red, its purpose fulfilled. It detaches from the stem and drifts gently down to the forest floor. Here, a new journey begins. The leaf becomes part of the rich layer of humus. Tiny microbes, bacteria, and fungi, the great recyclers of the forest, begin their work. They slowly decompose the leaf, breaking down its complex structures to release the nutrients back into the soil. In this process, the carbon atom from our graphite grain is released. It combines with oxygen from the air and becomes a molecule of carbon dioxide. For the first time since it was forged in the heart of a supernova, our atom is a gas. It is weightless, invisible. It drifts up from the forest floor, rising on a gentle current of air. It joins the Earth's atmosphere, a vast, swirling ocean of gases. It may travel for thousands of miles, carried by the jet stream high above the clouds. It may circle the globe many times, a silent, unseen passenger in the wind. It is part of the air you are breathing now. Let us follow that single molecule of carbon dioxide. It drifts on the wind, over fields and cities, for days or weeks. Then one evening, it drifts through an open window, into a quiet room where someone is resting, just like you. That person takes a slow, deep breath. And our molecule, with its ancient carbon atom, is drawn into their lungs. It passes through the branching pathways, into the tiny air sacs, the alveoli. Here it passes through a thin membrane, into the bloodstream. It is picked up by a red blood cell, by a molecule of hemoglobin, the very iron of which was forged in a different supernova long ago. For a moment, our carbon atom is part of a human being. It travels through the body, a part of the great, warm living system. It is carried to the heart, and then pumped out to every cell. It is a witness to the quiet miracle of a living, breathing body. But its stay is short. The body has its own cycles. The carbon dioxide is a waste product. It is carried back to the lungs. And with the next gentle exhalation, it is released back into the room, back into the atmosphere. The connection was brief, but profound. The stardust from a long-dead star was, for a moment, a part of a living, dreaming human. Let us follow the journey of the strawberry itself. A bird, a cedar waxwing with a soft, brown crest, plucks the ripe, red berry from the plant. It eats the sweet fruit, and with it, it consumes thousands of carbon atoms, including some that were once part of our graphite grain. These atoms are now part of the bird. They become part of its muscle, its feathers, its very being. The bird is a creature of the air, a traveler. In the autumn, it feels the ancient call to migrate. It joins a flock, and they begin a long journey south. Our carbon atom, now part of the bird, travels with it. It flies over forests and fields, over cities and rivers. It soars on the thermal updrafts, a tiny part of a great living vessel. It crosses the Gulf of Mexico in a single epic flight. It has left the quiet forest and is now on a journey of thousands of miles, a journey powered by the sun, a journey that follows the ancient magnetic pathways of the Earth. The Stardust has taken flight. After its time in the air, our carbon dioxide molecule drifts over the vast blue expanse of the Pacific Ocean. The surface of the water is in constant exchange with the atmosphere. Our molecule dissolves into the ocean. It is now part of the great oceanic carbon cycle. Here it may be taken up by a microscopic organism, a tiny phytoplankton, a single-celled plant that floats in the sunlit surface waters. Like the strawberry leaf, this phytoplankton uses the carbon atom to build its body. It lives its short life, a tiny spark of green in a universe of blue. When it dies, it sinks. It drifts slowly down, through the twilight zone where sunlight fades, past strange and wonderful creatures of the deep. It settles on the ocean floor, becoming part of the deep-sea sediment. Here it may be locked away for thousands of years, a tiny part of the Earth's memory, written in layers of mud. Or perhaps, our carbon atom is released back into the water, and is carried by the deep ocean currents, a slow, cold river that circles the globe over 1,000 years. It may travel from the Pacific to the Atlantic, and back again, a long, dark, silent journey. Eventually, in a place of oceanic upwelling, it may return to the surface, and be released back into the atmosphere, to begin its journey anew. And what of our other traveler, the silicon carbide grain? It is incredibly tough, one of the most durable materials in nature. It does not easily become part of the biological cycle. It remains in the soil, a tiny, silent, physical messenger. It is a witness. It is an anchor to a time before our world began. While the carbon atom dances through the cycles of life, death, air, and water, the silicon carbide grain persists. It is a constant. It has witnessed the birth of the soil from the slow decay of rock. It has felt the gentle pressure of roots from ancient forests, long since vanished. It has seen the changing of the seasons, countless times. It has been warmed by the sun of the Jurassic, and cooled by the rains of the Pleistocene. It may be washed into a river and carried to the sea, where it will settle on the deep ocean floor, a tiny glittering speck in the darkness. There it might rest for eons, buried in sediment that slowly turns to stone. And one day, millions of years from now, the slow, powerful dance of the continents, the great engine of plate tectonics, may lift that seafloor. The stone will be pushed up, crumpled and folded into a new mountain range, to see the sun once more. The wind and the rain will once again begin their patient work, and eventually, after an age, our grain will be freed, to be washed into a new river, to begin another chapter of its terrestrial journey. Its journey is one of physical endurance, a testament to the incredible strength of the crystal lattice that holds it together. It is a story of permanence in a world of change. It is the anchor, the historian, the physical proof. The carbon atom is the traveler, the participant, the lifeblood. One is the story of rock, the other the story of life. Both are stardust. Both are on an endless journey. One tells a story of resilience, the other a story of transformation. Together, they tell the story of the universe, a story of both constancy and endless,
Let us follow our
silicon carbide grain into the deep future. It lies buried in a sedimentary rock layer, deep beneath the ocean floor. The pressure is immense. The temperature slowly rises. Over millions of years, the rock is metamorphosed. It is cooked and squeezed, its minerals recrystallizing into new forms. But our grain of silicon carbide is stronger than the rock around it. It survives this transformation, a tiny ancient inclusion in a new kind of rock, a schist or a gneiss. The plate tectonics continue their slow, inexorable dance. The oceanic plate carrying our grain is slowly subducted beneath a continental plate. It is dragged down deeper and deeper into the Earth's mantle. The temperature and pressure become unimaginable. The rock around it melts, becoming part of the great churning magma of the mantle. But even here, our grain may survive. For a time. It is a tiny, solid crystal in a sea of molten rock. It is carried on the slow convection currents of the mantle, a journey that can last for hundreds of millions of years. Eventually, this magma may rise to the surface. It may erupt from a volcano, a spectacular fountain of fire and ash. Our grain, carried within a droplet of lava, is thrown high into the atmosphere. The lava cools and solidifies into a new volcanic rock, an igneous rock. Our grain has returned to the surface of the earth, encased in a brand new home. It has completed a full cycle of the Earth's rock cycle, a journey from the sky, to the soil, to the sea, to the deep earth, and back to the sky again. And what of the far, far future? In 5 billion years, our sun, like the red giant that created our first grain, will come to the end of its life. It will swell into a red giant itself. Its outer layers will expand, engulfing Mercury, Venus, and perhaps the Earth. If our carbon atom is in the atmosphere at that time, it will be swept away by the sun's powerful stellar wind. It will be pushed out into interstellar space, to begin a new journey, in a new molecular cloud, to be part of a new solar system, yet to be born. If our silicon carbide grain is on the surface, the Earth will be vaporized. The grain itself, incredibly resilient, may survive this final fire. It too may be cast back out into the void, a twice-traveled grain of stardust, carrying the memory not just of one, but of 2 solar systems. The cycle is endless. The universe is in a constant state of renewal. The end of one story is always the beginning of another. This tiny grain is a physical link to our cosmic origins. Its very existence here on Earth is a testament to the incredible interconnected journey of matter and time. And its story is your story. The journey of this single patient speck of dust mirrors the journey of every atom inside of you. For you too are made of the same ancient material. The atoms within you have also taken this long, incredible journey. An atom of carbon in your hand might have come from a star just like the one in our story, a gentle red giant that breathed its creations into the void. An atom of oxygen in your breath might have been forged in the heart of a supernova, flung across the galaxy in a brilliant explosion, just like our second traveler. You are the universe, experiencing itself. You are the living, breathing result of this cosmic recycling, of stars living and dying so that new things like strawberry plants and like you could come to be. You are a collection of memories from countless ancient suns. And now, your own journey for today is over. It is time for you to rest. Like the stardust grain, which has found its final peaceful resting place here on Earth, you too can find your stillness, find your peace. Allow yourself to feel the deep, quiet connection to the universe, to the stars from which you came. You are a part of it all. Feel that connection now, a sense of belonging to something vast and ancient and beautiful.